Okay, last problem. If I take the limit as n approaches infinity of e to the n over n squared, that's infinity over infinity, by L'Hopital, that's the limit as n approaches infinity of e to the n over 2n, that's still infinity over infinity. L'Hopital again, that's the limit as n approaches infinity of e to the n over 2. That would be infinity, which is not 0, therefore converge by, oops, diverge. Look at that. By test for divergence. So anytime you say converge or diverge, you have to say by what? Anytime you're using geometric from now on, you're going to use the letter G and the letter R. Those are associated with geometric series. On the next problem, set of problems, it says find the values of x for which the series converge. X doesn't come up until really section 11.8 and on 11.8, 11.9, 11.10. So there is no x up till now. We're dealing with the hard part, which is the coefficient of the series. And it says, this is the key, guys. It says find the sum of the series. We know how to find two sums only. And since I didn't tell you what the other sum is, you should know that we're talking about geometric. So glance at this for a minute. Do you see that this right here is raised to the n power? That looks like a to the n. Remember, geometric series are exponential, except the base of an exponential function must be positive. Geometric allows it to be negative. Or 0, I guess. So, if I treat this like a geometric series, wouldn't you say R is actually x plus 2? Not a traditional R, but that's what it is. If I list some of those, that's what I'll be looking at. An absolute value, if that's less than 1, this will converge. Now I have an absolute value equation or inequality. I know how to deal with that. I took algebra back in my days. Subtract 2 from each side. As long as x is between -3 and -1, this series will converge. And what that does, that value will guarantee that this right here is geometric with that holding. The same deal on this problem. I'll say that's the series n equals 0 to infinity. And if I combine those to make it look like a geometric series, remember geometric series is something raised to the n power. So I would say R is the absolute value of negative x 4 into x minus 5, and I want that to be less than 1, right? Absolute value will absorb the negative. So if I look at 4, actually it's easier to go, yeah, I guess it's fine. 4x minus 20 is less than 1. That means 4x minus 20 is between -1 and 1. And I can solve that. Add 20 to both sides, that's 21 divided by 4. No, not equal, and let's flip, right? And if you add, that's 19 divided by 4. As long as x is between those values, you're guaranteed that this R is less than 1, and therefore this will converge. Right? And how about the last part? I didn't find the sum yet. I'm going to find the sum, then it says find the sum. As long as this is geometric, sine of x over 3 raised to the absolute value, raised to the n power. So I can see that R is the sine of x over 3, and I want that to be less than 1. But the sine of x, right, over 3, or the sine of x is less than 3. That's true for all x. No matter what sine equal, this value between 1 and -1, this is 3, and a value between 1 and -1 divided by 3 will always be an absolute value less than 1, which means this will converge for all values of x. Okay, let me fix that. Converge for all values of x. Now let's find the sum. The sum on the first one is the very first term. What's the very first term? Throw 1 in there. x plus 2 divided by 1 minus r. Right? So that is actually x plus 2 divided by so I can take a negative up front because both of these are negative. X plus 1. There we go. You could say negative x minus 2 minus 1. Here, the very first term, if you put 0 in there, you will get a 1 over 1 minus r, and r happened to be 4x minus 2. Right? Highlight. 1 minus r happened to be a negative 4 into x minus 4. And again, this is fine for the exam. And here, this infinite sum will equal the very first term. Throw 0 in there, you get a 1 over 1 minus r. That's fine for the test. Of course, this will be 3 over 2 minus the sum of x. You should do that with homework. And this will be 1 over, that's a plus, 4x minus 20 plus 1 is minus 19. And then this. Now to the last part of this lesson. Next up, we have a definition. This is the only section, this is the only definition in this chapter in which you don't put this definition. This is what it says. If you have an infinite sum, let S sub n is stopping this, not going to infinity to n terms, listing the first n terms. Right? Let S sub n equal that. They say, given this infinite series from 1 all the way to infinity, if you look at a finite sum, if the sequence S sub n, a finite sum, this is, I could find a formula for that, and that becomes a sequence. Right? And if I take the limit of this finite sum and get a number, real number, not infinity, then I'll say the infinite series will equal that sum, and therefore it will converge. And that's, otherwise, if that doesn't happen, we'll say the series diverge. So, I'm going to walk you through as we do examples. A bit hard to follow, but a couple of examples hopefully will clear that up. I'll give you a few hints on it. Okay, number 4 is pretty much good as a starting point for this. They say we have this series. Notice this series is infinite. They were able to find a partial sum. They were able to find the series n equal 1, I equal 1 to n of a sub I. They got that to be n squared minus 1 over 4n squared plus 1. It turns out that's the most work. That's what they got. So somebody figured out the sum from 1 to n of this a sub n equal to this. If you were able to do that, then that's going to be the most work for us. If somebody figured that out right there, what we're going to do, we're going to take the limit as n approaches infinity of this s sub n, which is the limit as n approaches infinity of n squared minus 1 over 4n squared plus 1. Normally I work downwards, but you know what, let me work downwards. Otherwise, on a test you're going to say, wait, but you did that example that way. Look at that, I missed half of it. I can fix that. And I'm going to say that is the limit as n approaches infinity of dividing by the highest power term of the denominator. I could use L'Hopital. That is 1/4. Therefore, converge. Not only that, I'm going to assume the sum n equal 1 to infinity, you guys, equal 1/4 as well by this theorem. This theorem says you have an infinite sum. That's this part. If you can find a finite sum, s sub n, in which you're stopping at a given point from I equal 1 to n, and that's what they did, somebody found that for us, then take the limit as n approaches infinity of this finite sum. That's what I just did. And if you get it to be a number, then that series will converge and the sum will equal that 1/4. And this is the only place where you could say converge or diverge without quoting anything. Otherwise, you have to quote something. On the next problem, determine whether the series converge or diverge. If it converges, find the sum. That's the key. If I take the limit as n approaches infinity, that would be the sine of 0, which is 0, 0. I don't know whether this converge or diverge. It doesn't match anything else I know. It's not geometric. So that's a key for me to try and figure out S sub n. That is, if I start with n equal 1, that will be the sine of 1 minus the sine of 1 over 2 plus n equal 2, the sine of 1 over 2 minus the sine of 1 over a 2 in there will give me a 3. I would keep them as sine of 1 over 3 minus the sine of 1 over 4. This is called telescoping. Now, if I notice those two cancel out, and I also notice that those two cancel out. Once one full term cancel out, I know that everything's going to cancel out. This is going to cancel out with the next one. So anything in between is going to cancel out. I will stop, no need to list more. I would list the very last term. The very last term is literally what you see. And since we are very observant, we notice that the second term canceled out. We need one more term. If I go back, the sine of 1 over n minus 1 minus the sine, and if I go one below, isn't that 1 over n? And maybe one more just for you to see it. The term before that is the sine of 1 over n minus 2, and the term before that is sine of 1 over n minus 1. Just like we canceled the first, we notice toward the end, this and that cancel out, and those two cancel out. Once one term cancel out, I know everything is between is going to cancel out, and S sub n is really the sine of 1 minus the sine of 1 over n plus 1. Once I get this far, now if I take the limit as n approaches infinity of the sine of 1 minus the sine of 1 over n plus 1, that will be 0, and the sine of 0 is 0, so that is the sine of 1. Then I will conclude it converge. Not only that, I'll conclude that the sum n equal 1 to infinity of the sine of 1 over n minus the sine of 1 over n plus 1, all of that infinite sum equals the sine of 1. And that's my conclusion. Pretty cool, huh? And on this problem, I want to, and they tell you use telescoping. If they didn't, if they say find the sum, the limit as n approaches infinity, this will approach 1, and natural log of 1 equals 0. So out of luck with tests for divergence, but I could say this is the series n equal 1 to infinity of natural log of n minus natural log of n plus 1. So if I want to find n terms, I start with the first, plug 1 in, that's a 0, that's okay, I know, plus natural log of 2 minus natural log of 3 plus natural log of 3 minus natural log of 4, and I notice the same thing happens. Those two cancel out, and those two cancel out. Once one term cancel out, I will say no need to list more. I'm going to list the very last term. The very last term is literally what I see, and a term before it, and again, I'm observant. I notice the second term canceled. That's as far as I have to go. I notice those two cancel out, and this is going to cancel with the one before that. If you don't see that, list another term. So S sub n is actually natural log of 1 minus natural log of n plus 1. As n approaches infinity, the limit as n approaches infinity of, this is 0, right? Isn't that negative infinity? Therefore, diverge. And there's the homework.